analysis related to application of statistics in historical research. So in the last video, first it is explained all the small cell of images, or this is a poster of application of statistics in historical research, and this poster has been made by 30 small images. As already told, that all the images are reflecting that what will be discussed in this video overall. So I'm not going through in detail in this video, because it is already informed in the previous video, correlation, regression, everything. But today what I am going to start from this portion, because in the last video up to this extent it is explained, that is use of statistics, especially the basic statistics, and the my standard deviation, why it is important in historical research, definition of standard deviation, growth rate, everything is already discussed, and the summary of analysis is also discussed, and what are the relevant historical research where we can able to apply the small or basic statistical tool. It is also up to this extent it is explained what was the average tax revenue during a ruler's reign, that is mean we have to apply, what was the typical size of land holding in a village, that is we have to apply median, which occupation was most common in medieval town, that is mode, where agricultural yields stable or highly variable over time, we have to apply standard deviation. When the research questions are like this, what percentage of population was literate or illiterate, like this it will be percentage. How rapidly did population, trade, industrial output grow across decades, growth rate. So these measures transform historical records into quantitative evidence, enabling the historians to identify pattern, compare periods, and support interpretations with data. Up to this extent it is explained. Now today's part is time series analysis. Actually the purpose study historical trends over time. For example, a researcher examines the rice prices. Price is one column, first column the year, price is another column, per kg. So if we plot this data into graph, so there will be a tendency of upward rising trend, because the price increases, the trend shows continuous price increase, indicating inflation or supply shortages. It may be correlation analysis. It is also explained what is correlation analysis. Now in this video we want to show how manually or we can able to calculate this correlation coefficient. Suppose the hypothetical data is amount of rainfall, it is given in centimeter in different years, 5 years, and crop yield in tons, okay, in a particular rain. So high positive correlation, that is R equals to 0.99, suggests better rainfall was associated with higher agricultural production. Suppose after the application of formula, the value of correlation coefficient came 0.99. So how can we explain? It suggests that better rainfall was associated with higher agricultural production. This will be the conclusion. Now the question is, what is the formula? How can we calculate the R? The Pearson, it is known as Pearson correlation coefficient. The formula R is equals to xi minus x bar. Xi means this one, okay, the independent variable, and dependent variable is crop yield. So yi minus y bar. Y bar means y mean. So x mean and y mean we have to calculate, and divided by summation xi minus x bar square into summation yi minus y bar square. This is the formula. So one scholar should have to remember this formula. Okay, the simple linear regression equation is y hat, it is known as y cap or y hat, is equals to a plus bx. This is the standard equation, linear regression equation. So in terms of mathematical or symbolic term, it is used in this way, and the formula for calculating R is equals to like this. We have to remember this, and how can we apply this one? This is showing. Okay, and another thing is the regression coefficient beta or beta hat can be calculated by using this formula. Huge similarity is there with beta coefficient and R. Okay, xi minus x bar, yi minus y bar, xi minus x bar, y minus y bar. Here it is xi minus x bar, yi minus y bar. Instead of these two, here it is xi minus x bar square. That is the independent variable square. It is used. So we have to, the researcher is definitely remember the formulas. Okay, after that how can he proceed? This can be explained with the help of this hypothetical example. As a hypothetical historical example, suppose a historian studies literacy and voter turnout in 5 districts. Okay, so now we are going to apply the rule, or the tool, that is R, the correlation coefficient. Why? Because the historian is going to explore the association between the percentage of literacy and the turnout in voting turnout. That means voter turnout. Okay. So using this data, the correlation is like this, indicating an extremely strong positive association. The estimated regression line is, again, if we apply the regression, it looks like this. As I told you, in the regression line, alpha or A is the intercept. Is the intercept. Okay? Intercept means that portion which that is the value in the y-axis. Okay, in the vertical axis. So if the curve is like the straight line, so the line where it is cutting or touching the y-axis, that portion is A. When the value of the independent variable is 0, what is the value of dependent variable? So that is A, intercept. Okay, so this is intercept. So if there is literacy is nil, still there will be voting turnout 14%. Look will go for casting their vote. So this is the intercept. So if the value of independent variable is 0, what is the value of dependent variable? This is the intercept value. Okay, and this is the slope value 0.90. 0.90 means with 1% increase, in literacy, there will be change in the voting turnout will be 0.90%. Okay, so in this way it may be explained. So we need to take the data through our report or documents, and we need to apply this tool to calculate the correlation coefficient as well as the regression coefficient. Okay, now how a historian can explain? A historian would explain these results cautiously. Districts with higher literacy tended to have higher electoral participation, and the model suggests that each additional, model means regression model, suggests that each additional percentage point of literacy was associated with about 0.9 percentage point increase in turnout. With 1 unit increase of literacy, it will increase the voting turnout as 0.9 or 0.90, since there is plus sign. So these relationships are positive. With the increases of 1 unit of one independent variable, what is the change in the dependent variable? That is 0.90. Okay, 0.90. So positive association, and we are getting positive association from correlation coefficient, and here we are getting the quantitative the pattern, with the increase of 1 unit of the independent variable, how it is reflecting the dependent variable. So in this way, these two tool, statistical tool, correlation and regression, is helpful for explaining such kind of analysis. The historian would emphasize that correlation and regression reveal an association, not necessarily causation, would seek the corroborating evidence from contemporary records, educational policies, and other socio-economic factors before concluding that literacy itself caused the increase in political participation. So it implies that there is association between, with the increases of literacy, the voting turnout increases, but it does not tell the causal relationship. So there may be many other factors, okay, that may influence the voting turnout, not only the literacy. It is not that with the increases of only literacy, turnout to the voting turnout increases or something else. Not necessarily causation. Would seek to corroborating evidence from contemporary records, educational policies, and other socio-economic factors before concluding that literacy itself caused the increase in political participation. Okay, so it is the regression is the predicting the variable with respect to the independent variable, with the increase of 1 unit of independent variable. What is the change? Whether does there exist any relationship between dependent or independent is the correlation, and that is degree of linear association, and this is the change of dependent variable with the increase of independent variable. Okay, so these are the basic thing of correlation and regression. So regression analysis, here again it is explained to measure the impact of one factor on another. The research question: did literacy influence voter turnout during the colonial election. Okay, so here it is literacy rate, it is voter turnout. Okay, literacy voting turnout. So suppose the result is like this. So it implies every 1% increase in literacy associated with about 0.88% increase in voter turnout. So this regression can be done using Excel. Okay, using Excel, this regression and this correlation can be explained with the help of Excel. Okay, so I'm showing this how can it be possible in the Excel. Okay, just showing it. You just copy this data. Okay, go to your Excel file. Go to your Excel file. Suppose this is your Excel file. You open your Excel file. This is your Excel file. Open the Excel file. How can you draw this correlation regression? This is your data. Copy paste option. This is your data. So literacy and voter turnout. How can we apply the correlation? Okay, so first go to data. First go to data. After go to data, look, this is the data analysis is coming out. Now every computer it is given, but we need to extract this one. Okay, directly you cannot able to get this data analysis just by clicking data. So what you have to do, first go to file, then go to from file to suppose data analysis tool pack. Here it is given. Okay, option is given of option. From option you have to click add in. From add in, click add in, then analysis tool pack. You click analysis tool pack, click OK, it will come. Okay, so you need to check this one first, so the data analysis will come. Okay, otherwise you cannot able to proceed. So you put the data into Excel. This is the district or whatever it may be. It may be country, it may be state, whatever it may be. Percentage of literacy, what you got the data from your report, from your documents, and voter turnout or whatever may be the other variables. Okay, now go to data analysis. Go to correlation. Here it is known as correlation. Correlation is known, showing it correlation. Okay, now input range is from here to here. Input range. Okay, don't clip this one, only the two variables, independent dependent variable input range. And since we have taken this the title also, literacy and voter, so you need to click here labels in the click, because title is, if you do not take the title, then you can take from this portion also. Now click OK. Okay, click OK. This is correlation. It will provide the correlation. The result may be in the sheet 1, sheet 2. No, it is given. This is the result. Okay, the result is has given in sheet 2. The result will go to another sheet. Okay, this is 0.99. Okay, this is the correlation. Voter turnout and literacy correlation 0.9. In this way, we can able to calculate the correlation. Okay, now I am showing how to regression can be done. So go to regression. Similarly, go to data analysis. Here it is. Just check where the regression. If you go click the downward, you can see the regression. Click regression. Click OK. Click OK. Now the input y range. So input y range means the dependent variable. We generally use y means dependent variable. What is dependent variable? So dependent variable is voter turnout. Voter turnout is the dependent variable. Okay, this is voter turnout. Similarly, input range. Input means independent variable. Literacy is the input range. Okay. Now I am not giving labels here because I am not selecting this portion. Okay, so not clicking labels. So it is keeping is as it is. Now click OK. This is the result. Okay, this is the result of regression. You will get this result. Okay, you will get this result. What is the value? So you only need this value. Intercept means 20.2, and the beta hat, that is the coefficient value, estimated value of coefficient that is related to x variable or independent variable is 0.88. We need just these two values. These two values. Okay, so in this way we can able to calculate. Now coming to our original portion. So you know how to calculate correlation and regression, and after getting this thing, look, 20 plus 0.88, 20 plus 0.88. Okay, we got the same result, 20 plus 0.88 into literacy rate. So the interpretation will be like this: every 1% increase in literacy is associated with about 0.88% increase in voter turnout. In this way we can explain this. Next, coming to index number purpose, compare historical changes. Example, taking 1900 as the base year. So price index is 1900 is 100, then 115, 145, 180. How can we explain that? From 100 to 180, from base period to 1930, there is the 80% increase in price. That is, the price rose by 80% between 1900 and 1930. So in this way, with the help of this data, using the price index and year, though there are various formulas are there for calculating price index, not going through in detail, but if you have this data, you can explain in this way. Now another important test, that is known as chi-square test. So this tool is very important and essential in many research work, especially in the social science. Not only social science, chi-square test is also applied in pure science also, especially the biology and other management. Many other subjects use this chi-square test. So this is very important. Once you can able to learn this this test, you can able to apply in many cases. So what is the purpose? The test association between categorical variables. So categorical variable means this is not quantitative variable, categorical variable. Okay, we can able to measure in terms of low, medium, high, in this way. Okay, so what is the research question? Was education associated with military recruitment? Was education associated with military recruitment? Okay, so the military recruitment will be like this: yes, recruited or not recruited, recruited or not recruited, yes, no. Similarly, the education is literate or illiterate. Okay, it is classified into two ways. It is not that how many years you have education, 5 years, 6 years, 7 years. So it is not quantitatively defined. It is defined categorically. That is why the chi-square test is associated with testing the relationship between categorical variables. So one category is education, and it is explained in this way whether it is literate or illiterate, and the another variable, categorical variable, is whether recruitment, whether recruited or not recruited. So in military, many illiterate persons are also recruited because of barber, cook. They also need for recruiting such kind of people, the cook, the barber. So education does not matter, only their quality is the matter. In that case, we can able to apply chi-square test. Chi-square test that can determine whether recruitment dependent significantly on education, or in other words, does there exist any relationship between the education and recruitment in military? Okay, how can you proceed? So let's O denote the observed frequency. Observed frequency means what you got from your data. Okay, you got that 80% recruited, those who are literate. Okay, with respect to their education, they are literate. Literate may be, suppose you take Madhyamik graduate or Madhyamik, whatever it may be, literate. Okay, and this is 80. And literate but not got the opportunity, 20 out of 100. 20 not got the opportunity, though they are literate. There is no hard and fast rule that all literate persons will get the opportunity. So 20 not recruited means not got the opportunity in the military service. And among the 100 illiterate persons, 50 got recruited and 50 not recruited. This is the data that you got. Okay, raw data, observed data. This is also known as observed data or observed frequency. Now, what is your task? Your task is to calculate the expected frequency. How can you proceed? First, you prepare this table. So recruited, not recruited, total is 100. So similarly, from illiterate, 50 recruited, 50 not recruited, total is 100. So this is known as row total. So you have to add the row, calculate the row total. Similarly, you have to add the column, calculate the column total. 50 plus 80, 130, 20 plus 50, 70. So this is column total. Then for calculating expected frequency, what I told that this is observed frequency, we have to calculate expected frequency. How can we calculate? Step 1, take the sum of row sum. So first row 80 plus 20, 100, 50 plus 50, 100. Then column sum 80 plus 50, 130, 20 plus 50, 70. So you need to calculate the row sum and column sum, and this is the sum of all over sum. Okay, total sum or grand sum, 100, 100, 200, 130 per 70, 200. So 200 is the grand total. Now, how can we calculate the expected frequency? So for each cell, you need to calculate expected frequency. This is cell number 1, suppose cell 1. So how can we calculate? Cell called row sum into column sum divided by grand total. So for this cell, if I click this cell, what is the row sum? 100. What is the column sum? 130. What is the total? 200. So for calculating expected frequency for cell 1, what we have to do? 100 into 130 divided by 200. For this cell, the row sum is 100 into column sum 70, so 100 into 70 divided by 200. So in this way, for 1 2 3 4 cells, we need to calculate expected frequency. For cell 1 1 1 2, okay, 1 1 means first row first column, 1 2 means first row, 2 second column. So first one is row, second one is column, 1 2. Similarly, E21 means expected frequency 2 means second row first column, 2 2 means second row second column, in this way. Okay, so in this way you have to calculate the expected frequency for all the cell. Okay, then what you have to calculate? Then you have to calculate the actual frequency or observed frequency minus expected frequency square divided by expected frequency. Simple. Actual frequency is 80, which is for cell 1 80. What is your expected frequency for the cell 1? Expected frequency is 65. So 80 minus 65 whole square divided by 65. In this way you need to calculate this value, 3.462. Similarly, for other cells, putting the same formula, so observed value minus expected value frequency square divided by expected frequency. So in this way we can calculate the value, these values. Okay, then adding all these value, you have to add 3.46, 6.42, 3.46, 6.429. If we add all these value, it gives us chi-square value 19.78. Okay, so one term is associated with degrees of freedom. So for chi-square distribution, another term that is related always come degrees of freedom. Degrees of freedom is row minus 1, column minus 1. How many row is there? 2 row is there. 2 row. How many column? 2 column. So 2 minus 1 into 2 minus 1. That is 1 into 1. 1. So degrees of freedom is 1. So if you see any chi-square table, you can see in chi-square values are given and the degrees of freedom is also given. So from the table value you can able to calculate what is the probability or p value for this chi-square value with degrees of freedom 1. Since chi-square value is at 19.78 is much more larger than 5% critical value. Critical value is given in the table. If you see Google that give me chi-square table, okay, so you can check it with respect to the table value. 3.84 for degrees of 1 degrees of freedom, we can reject the null hypothesis of independence. So the logic is, if this is known as our calculated value, if the calculated value is greater than the table value, we need to reject our null hypothesis. There exists statistically significant association between education and military recruitment. Null hypothesis means always negation. There is no relationship between the education and military recruitment. So null hypothesis always means negation, no relation. So there is no similarity. So for this type of situation or research issues, we need to put null hypothesis is like this. So if our calculated value exceeds the table value, how can we get the table value? Okay, through Google or any statistics book, the back side there is the table value is given. If you see the computed value, our calculated value is greater than the table value, then we take the decision, we can reject the null hypothesis. Okay, so there is a statistically significant association between education and military recruitment. In this way we can able to apply chi-square test. So in the next, so with this I am concluding the part 2 of this video. So in the third video on this topic, so it will be explained demographic analysis, because in one video it will be not possible to concentrate. Okay, so that's all for today. Thank you for your patience hearing. Thank you.